Very excited to welcome Ali Montazer to the stage, talking about migration and modernization. Ali is a Chief Technology Officer at Midland Credit Management, a leader in partnering with consumers to help them resolve past due debt and supporting their personal pathways to economic freedom. As CTO, Ali leads a team of skilled technical professionals and engineers who help develop, modernize, and maintain all of MCM software products and integrations to enable the organization's global workforce and support the millions of consumers MCM serves. Very excited to welcome Ali, and remember, we'll try and have questions towards the end. If not, Ali will be available after to answer them as well. Please have a round of applause for our next speaker, Ali. Thank you.
Thank you. Thank you, everybody. Appreciate that. So I know it's just after lunch, probably not the best slot to talk about migration, but I'll try to keep it a little bit less boring. A quick intro about MCM and what we do, because that helps understand where we are in our journey. So Midland Credit Management has been around for over like 65 years. We basically buy distressed loans from banks when it's charged off, and then we'll try to work with our consumers to give them a second loan to be able to pay off their debt, to get back to their financial freedom that they have. I'm sure you guys are from different industries. Financial industry, it's a little bit behind the curve compared to other industries. Like things that we are talking about now are things that I'm coming from retail. That's what we were talking on the e-commerce world probably 10, 15 years ago. So that's what makes our migration, our journey a little bit interesting. Let me go through this and talking about the challenges that we were facing. I'm sure if you look at the problem statement, it's something that a lot of our customers or even you might have been facing before as well. It's a challenge of having unstable environments and applications and no clear ownership by your teams, and then not be able to have the right focus on building new stuff, and your team is mainly doing firefighting. This was the main challenge that we were facing. We had to fix that problem. I remember, I was just telling somebody now that I remember when I joined Midland Credit Management 3 years ago, first week every day, we had a P1 issue. And these are issues that our customer service is on the phone talking to our consumers, and then suddenly all the system were just going down at that level. So it was a challenge for us. We had to fix that. We had to stabilize that. From that point to where we are now, that for past 10 months of the year, we only had like 11 P1s. So it's a big change. 11 is not still a good number, but compared to what we had like a daily basis, it's a big progress. To fix that issue, we had to come up with some principles for our migration and modernization. The principle that we chose was basically innovate faster. I know everybody has heard that, and a lot of companies trying to do that, but to do that, you need to think about what needs to be done to be able to innovate faster. That's a mindset change. That's how you need to change the focus from building application that is just serving one purpose and then keep building on top of that, to more like holistically look at your environment, look at your use cases, and be able to distribute them and scale them as much as possible. That's why that when we look at our migration and modernization, we didn't just look at the technology. We look at all three aspects of technology, people, and process at the same time. We had to rethink about how to organize our team, how we should change our operating model. We had to think about our architecture, what architecture we need to be aligned with that organizational change, and obviously the processes that can help us with that. Talking about the first aspect of it, organization, we had to think about what are we missing in the model. The first thing that came to our attention was the ownership. What our team and our developers didn't feel at the time was like they actually owning that feature, that components that we're building. We had modeled our team to work more as a factory, that they have the implementation team and we have a support team. The implementation team always were just hoping that thing doesn't break for 30 days, that warranty is expired, then pass it to the support team and let them to take care of that. Very, very disconnected. And you can guess what will happen. Dev team doing the implementation, they do some work, wait for 30 days, operation gets the code, they receive defect, they start adding fixes to the code that they absolutely have no idea what it is. And then at the same time, our business partners coming up with the new requirements, and then guess who is gonna re-implement it? The original team. So they get a code that is touched by someone else and they didn't even know about it. So that was the loop that we had. We had to change that. We had to say, no, ownership is important. So you need to own the whole life cycle, not just for 30 days during the warranty period. Part of that is accountability. If you are owning your code, you need to be accountable for it. And that accountability may not be that easy to switch to. Like, I remember the complaints I was getting those days from my dev team was like, so what does that mean? Like, after 30 days, now I have to fix my code? I said, yeah, you build it. Does that mean that I have to wake up at 4 a.m. to fix the problem if there is an issue? Absolutely. And the answer was, if you don't like it, you may want to pay more attention when you're doing the implementation, have a better quality code, that you don't get calls at 4 a.m. every night. That's the accountability part that we had to push. One of the other challenges, and still a little bit we have it in our own organization, is the authority was at one level, centralized, and typically top-down. Nobody was doing anything unless the person who's sitting on top saying, okay, go do that. And unfortunately, that was in our culture, that our teams basically were reacting to somebody's giving them the direction, and then they were just going after the problem and fix that. We had to move that away from the central part, from the top, to the actual team, saying, nope, you have the power, you are empowered to make those decisions. If you have the accountability, if you have the ownership, and if you're making decisions for yourself, you should feel proud of what you've done as well. This is how we close the loop, that you're doing all of these things. Now you feel that you own this, you be proud of what you've done. And then that's how we create the professionalism. That's how we can create the skill set, the focus, and the specialty in our teams that is not just generalist. You actually have a specialist in your team. And all of these together will go back to our innovation flywheel that will help them all connect together. I'm not going to get to the detail of every single one, but from focusing on mainly the ownership, this is the areas that we focused on and try to change. Traditionally, we were very much a project-based organization. Still we are to some certain level, but everything was defined as a project, not a product. The problem with project-based mentality is like you always have a start and end date. That's a definition of a project. So your team feels like, okay, I'm done after the project ends. That's not the case in a product-based mentality. You own that. By going back to that sense of ownership, you own this product. You want to have it as a product that you own, to be able to maintain it, to be able to add to it, to be able to optimize it. So that's a shift that we had to do from projects to products. Autonomy, I talked about it. Again, it's important. It was really important for our team to feel that they are empowered to make those decisions, to be able to achieve the goals. And then empowering, it's a combination of all those together. And sorry, I'm keep looking at that because this monitor doesn't work, so. And, oh, looks like we have this again showing up. Just move away. All right. Now talking about organization itself, how did we form up our teams? In the PD team, product development team, we decided to separate out engineering from the architects. And when we're talking about architects, we're talking about high-level solution architects. The reason behind that was we don't want to have too many solution architects and have an architect for every single team that we are doing. So we had to think a little bit differently. Part of the process changed. We changed our model, implemented an intake solution for all the requests from our business team to go through this process of intake. And we have 1 week of intake process. We are putting our architects in the front of that intake process to look at the requirements, look at the ideas, and then try to do very, very high-level solutioning. They basically just do high-level solutioning, then break it down to different teams and pass it to an engineering team. Our engineering team, we formed out to have a basic DevOps type of team, then a Scrum team that has an SDM as the manager for that team, and a Scrum Master, a technical product manager, which I'll talk about why we call it technical product manager, and a bunch of engineers. It could be developers and testers. I mentioned that our organization is very much a project-based organization, so we don't really have product management component in our business side or even in our IT side. So we had to introduce a role in between as a technical product manager, somebody who has technical background, but is not just a BSA, a business system analyst. It's somebody that owns that product, will try to define the roadmap for the product by talking to business. So that's the role they introduce here, and then we have engineers. These teams, we decided to have like a 2-pizza team size for them, like 6 to 8. You know that a study shows that the most performing team is about 5.6, so we went to 6. We just add a few more, sometimes it's needed to make sure you have the right balance. But that's 6 to 8 team members that we decided to have for each of our Scrum teams. And these teams will act more like startups inside our enterprise. And by that, what we mean is they follow the guidelines and guardrails that we have set up for the organization. We'll make sure, I can't even read from there, sorry. They are responsible, as we mentioned, accountable for services that they build to be always up and running. And they need to feel that they own the whole SDLC, as we talked about. That's how we could implement that. That's okay. I think we're almost, yeah, thank you. I'll try. So that was more like a people side. From architecture side, let's look at some of these. So please pay attention to this slide because I'm going to ask questions on the next slide on this. But joking aside, what you see in this slide is what we had before. Those 2 big boxes in the middle, they are not ESPs. They're actually applications that we had and still kind of exist. You can see that how complex the environment was. And if we wanted to make any changes, it was almost impossible to be able to make those changes without breaking anything. So we tried to change that to this one. Actually go back maybe a little more. This is it's not a reference architecture, it's more like a pattern that we put in place for anything that we're doing moving forward. Financial systems and services, traditionally we have a lot of in-house solutions and in our own data centers. Even if you buy something from outside, most likely you have it in your own data center. It's not really a cloud-based solutions. So we couldn't just close everything, do a lift and shift, and move everything to cloud. We still had to keep them on our data centers. But the solution was not scalable. I cannot keep adding CPUs and racks after rack to make sure that it is scaling up based on the needs of my business. So we had to come up with a new architecture. This is what we could do. If you look at it on this side, we're still using our own data centers for on-prem solution. And these are, again, old monolithic applications that they don't know about events or they cannot even generate events. So what we decided to do is, let's simulate the events through CDC, like capture data changes. So we put CDC in place. As soon as something gets changed in our database, we will stream it to our cloud, which is AWS solution. We are using SQL Server on-prem, but doesn't matter. You can implement any CDC solution in your cloud of choice. What it happens is all the data gets populated through different shards to our AWS. But these are multiple different shards that we put in place to make sure data gets to AWS as soon as possible. And typically, different sets of data gets to destination at different times. To make sure we have the right state of data, we put Mongo there. This is actually one of the main use cases for Mongo that we implemented as the aggregator. So all the data goes in. We receive those based on the timestamp that we have attached to each shard and the data that it gets there. We are using Mongo to put those together in form of a document and then have that document ready for the events that Mongo generates. Mongo will receive those data, generates the events for our microservices. Each of those will receive those events and then do the processing that is needed. Again, Mongo, we use them for as a data storage for those services as well. If I use this architecture, in the next slide, I can show you in one of the use cases that we implemented. And that's for our omnichannel solutions. So again, on the left side, we have the on-prem database that pushes the data through Kinesis to AWS. Mongo receives those data, act as an aggregator, all those events being generated. And then different services, as you can see on the right side, either for email, SMS, call, they use exactly the same pattern. As soon as we want to introduce a new channel, we just add the service to the right side, and then an event being generated, and those data will be processed and send whatever communication needs to be sent out. As an example of what has changed, in our legacy solutions, this is mainly specifically for marketing letter solution that we implemented. Before we implemented this solution using Mongo and AWS, we were able to only generate 14,000 letters in every single run that we had. I didn't put the numbers here, but even those single runs, we had so many issues with that we couldn't even successfully run most of those sessions. It would take us 5 days to process 1 million letters. And you can imagine, in our environment that is highly regulated and we are supposed to send a welcome letter and validation letter to our consumer almost in maximum by day 5, it's really important. So our business gets really anxious when they see those letters are not going out. And it would take us 5 days to do that. We had to run 450 execution per month to meet the volume that we needed. A lot of manual steps. Our business operations team had to go in and fix out those jobs, rerun the jobs to make sure the data gets there. And then obviously it was impacting everything else in our environment, because this solution that we had to send these jobs are actually use them for the actual calls for the customer service as well. And this is the result. So the serverless solution that we put in place, I can read it from here. We were able to, in each run, we were able to generate 720K letters. Compare that to like 14,000 that we had. It's like 50 times better. It would just take 16 hours to process 1 million compared to that 5 days that we had. And then 4 execution per month, 120 times better than before. We put a rule engine there that next time that they want to change their rules for sending those letters, they don't need to come to us to make the change in the code. They were just able to use Camunda as our rule engine to change the rules that they have and make those necessary changes. And then bandwidth of the whole solution, because again, it's moved out, it's completely distributed. We were able to scale up as needed for those few days that in a month that we had to send letters, and then scale it back down. So we don't even need to worry about our main solutions. But as you can imagine, everything is not that glorious and easy to be done. there are issues and challenges all the time. One of the issues that we had was DMS task. One thing I forgot to mention, our legacy environment, it's so complex and so many jobs are still running there that we can't even easily change or create a downtime for, like, let's say, even offline indexing. Everybody will say, why? Online indexing is better. That's a technology that everybody wants to use. But yes, but when you try to mimic or simulate your event-driven architecture using CDC, online indexing is not a good thing. Because as soon as the indexing starts happening, all those data being generated for each table for index will be pushed to AWS as well, which we don't need. But because of online indexing is all being pushed. And that's actually one of our challenges today that is still we are trying to deal with. But the other problem was the DMS itself, the AWS CDC solution, which is a single-threaded solution that doesn't help. The other challenge is inside the Kinesis itself, that they have a limitation of 1 MB for the message. Our data typically gets a little bit much bigger than that, so 1 MB is not that much. And then it's not really good for the bulk updates. On the Mongo side, it was actually kind of on our side. The model that we decided, the strategy that we decided to go in the first year was like, get your feet wet as soon as possible, learn AWS, learn Mongo, and then we'll fix it and refine it. And that's a model for Mongo that we use as well. What we did was we created one document and put all the data inside the document, which was great for the beginning. We had like, I don't know, 10 data fields. It was not that bad. But then we kept adding data after another one to the document, and it became so big that I was just talking to Josh when he joined our team, that our bill is just going over and over every month. We're just paying multiple $1,000s every month extra because of that document. So we had to change that. So we engaged Mongo professional services team. They came in and helped us to change the whole model. Instead of putting everything in one single document, have more like API calls to get the data as needed and then generate the events. And yeah, and I think that's mainly challenge and opportunities. And we have some time actually for Q&A. So thank you for your time listening to me. Here, you have any question?
You might want to put your headset on.
Sure.
Any questions for Ali? Yes. Right up.
How long did it take your team to get started with your first Mongo app?
Very good question. As I mentioned, we decided to go through the process of start as soon as possible, then fix it later. So the first app that we implemented and it actually got fully functional, it took us good 6 to 9 months, and it was hard because everything was new to my team, from the whole CDC, AWS, Mongo all together. So we faced some of the challenges that you may not typically face. Now when we are introducing a new service, it's less than 3 months, but at the beginning it was about 9 months.
Hey, great presentation. Question about the people part, right?
Yep.
The way you described it, it almost seemed like engineers didn't have like they didn't get a seat on the product table. Is that the case? Like, is all the documents and everything, product features driven still in a top-down manner?
Exactly. So if you notice here, I said that's the role that actually we created as TPM, Technical Product Manager, because we don't really have product management component in our organization yet. Mm-hmm. To bridge that gap, we said, let's create something in between, a person from a technology side, typically our own BSAs, what they used to be, becoming more product managers on the technology side. Somebody who we train them, somebody who has the product mentality now, can create the roadmap for the product with the look at technology to bridge that gap.
How do you align the business requests? I know they come in through the architecture group. How do they then decide which development team it goes to? So who's going to own that particular product?
Very good question. So that's our intake process. So typically they submit ideas, business partners, and then it goes to their directors and then decide we should look at it or not. Then we have an executive committee that look at all of those ideas saying, should IT even get involved with this or no, it's not worth it. When they approve it, our clock starts. That's the Monday discussion that they have. Tuesday, we have a high-level solutioning. High-level solutioning, mainly I have those architects that I talked about, the business representative, and then SDMs for other teams. So they get together, talk about or hear it from the business first, and then do the high-level solutioning. In that meeting, a combination of architects and SDMs decide, yeah, this component should be implemented with this microservice here, or that component should go to that team, and then they break it down. Next day, Wednesday, it's basically the SDM's time that they sit with the technical leads to do high-level estimation. We are still, again, the model I describe is more like we are water, scrum, fall type of model of implementation. We still need to get back to business saying how long it's going to take. So they put some t-shirt sizing estimation in terms of numbers and allocating resources, send it back to them on Friday.
Any other questions? That was great. All right. Well, we're so grateful to have customers, leadership, partners presenting today. I believe that was a fantastic presentation. Another round of applause, please.
Thank you.